Hello, this is Mr. Win. This video is about geometric mean. So, geometric mean is a number you calculate by multiplying the things together and then square rooting that new number. You generally use this technique in two different places. One is when you're given two numbers, and two is when you're given a right triangle made up of two more right triangles. So there'll be three right triangles. So if asked to find the geometric mean of two numbers, again, just multiply them together and then square root that new number. Now, in red, I wrote the steps mentioned above is actually a shortcut to do the work. To show the full work, you actually need to set a fraction or proportion. The first number goes over x, and that will equal x over the second number. So the first is find the geometric mean of 5 and 20 using both methods. So let's do the shortcut method first, and you can do either one, it doesn't matter. But just be able to recognize both. I'm going to do 5 times 20, and then square root that. So really, that's a square root of 100. That is a perfect square. That is 10. So 10 is the geometric mean of 5 and 20. Now here's the real work. It's the first number over x equals x over the second number. You already know how to solve fraction equals fraction, proportions. You're going to multiply each side by a denominator to get rid of a fraction. So let's multiply both sides by, 20 first. The first one is going to be 100 over x equals the second one. 20's cancel to x. I'm going to do the same step again. I'll multiply both sides by a denominator, in this case x. So here the x is canceled out. We get 100 equals x squared. And then you're going to square root it. And again, square root of 100 is 10. That's a perfect square. No work to show. But if you want to, you can do the tree branch method. So notice you get 10 both ways. Basically, when you multiply two numbers together, that's kind of like when you get rid of a fraction. And then when you square root, that's like trying to get rid of the square power for x. So again, just shortcut is multiply, then square root. So down here, do it for both methods. I'll multiply two numbers together. I'll show you what this is. 7 times 8, that is 56. Then I'm going to square root 56. Square root 56 is not a nice number. It's not a perfect square, so I have to break it down. We know 7 and 8, obviously. 8 is 2 and 4. 4 is 2 and 2. I find pairs. There's a pair of 2's. There's unpaired 2, unpaired 7. So a 2 goes out. Inside, a 2 and a 7 remain. Make sure you multiply back together. So the final answer is 2 root 14. All right. The second method, we'll do the fractions. First number over x, or y, doesn't matter, equals x over the second number. Get rid of fractions by multiplying by denominator. I'll do x this time. So this is 7 equals x squared over 8. Then I multiply both sides by 8. So 56 equals x squared. Then square root it. Do the tree branch. I do have the work on the side, so I'm not going to redo it. I'll just say 2 root 14 equals x. Alright, so that's how you find the geometric mean between two numbers. Even if there's three numbers, the same thing. You multiply all three numbers and square root that new answer. Alright, geometric mean also pops up or appears in problems involving three right triangles, like below. So notice that there are actually three triangles, and these are actually similar. There's a big right triangle, there's a medium right triangle, and a small right triangle. So I'm going to label all the sides right now. For the big right triangle, we know the hypotenuse is 21. That is this plus this together. The left side, the small side is x, and the long side is z. All right. Then and let me do like this. That was for the giant triangle, this one. All right, next I'm going to look at the medium triangle. So that would be this right triangle right here. The hypotenuse is z. The short side is y. The long side is 16. And last is the small right triangle, this one right here. The hypotenuse is x. The small side is 5. The long side is y. Alright, and like before, to solve similar shapes, you pair the sides, make the fraction proportion, and solve. I like doing circle over circle, square over square, stuff like that. So now we're actually going to solve the problem. We'll do the same problem, solve for x, y, and z. So let's solve for x first. So I want x, so I'm going to pair that. So this circle technically goes with this, but also goes with this. All the small sides go together, but ignore the middle triangle for now. I don't want that. I'm going to do the large triangle and the small triangle. X goes with 5. And 21 goes with this x, hypotenuse over hypotenuse. If I do circle over circle equals square over square, you know what? That's good, but let me actually do it in the order. Let's do square over square equals circle over circle. Square over square equals circle over circle. I did that to show you that the formatting looks just like geometric mean. Remember, a number over x equals x over that other number. So you can solve either one. I will solve the one in green. To get rid of fractions, you multiply both sides by a denominator. Let's do 5. All right, that makes our left fraction 105 over x, and the right fraction, the 5's cancel the x. Multiply both sides by x to go to the next fraction. To get 105 equals x squared. Then I square root it. 105 breaks down to 21, 5, 3, and 7, so 3, 5, 7. There's no pairs, so that is fully reduced. So we just found x. All right, let's find y. Now, once I know x and plug it in, I can use it for any other pair if I want to, but I don't have to. Again, it's your choice. I'm going to avoid using it. So to find y, here's y. Y goes with 5, and this other y, because I'm trying to find y, goes with 16. All right, so I can say y over 5 equals 16 over y. Same thing. Get rid of the fractions. Multiply both sides by y first in this case. Y squared over 5 equals 16. Multiply both sides by 5. Y squared equals 80. Square root both sides. 80, if you do the tree branch, you get 4 and 20. 16, 5. 4 square root 5. So you should be able to do the work for that. So I found y. Last, I want to find z. So z goes with 21. Oops. So we circle, pair, circle. And the other z goes with 16. All right, so let's do a circle over circle equals square over square. Multiply by a denominator. Multiply z's, you get a 21 equals z squared over 16. Multiply both sides by 16. You get 336 equals z squared. Square root both sides. I do know 336 turns into 21 and 16. That's 3 and 7. That's 4 and 4. So there's a pair of 4s. A 3 and 7 are unpaired, stay together. So that will make this z equals 4 on the outside, 21 on the inside. All right, so I found x, y, and z. All right, so it'll take a very long time to solve these problems. We're going to always separate the 3 triangles to find the proportions. So luckily someone discovered a shortcut, pattern formula. I'd highly recommend learning the following 2 patterns. And important note, you must always start at one of the small parts of the largest hypotenuse. All right, you also need to know the entire hypotenuse, so 10 plus 4 is 14. All right, the first pattern is called around the world. You start at one of the 2 small pieces of the large hypotenuse, so I'll start at 10. Around the world makes like a half circle. 10 will go to y, then y will go to 4. And each arrow is a fraction, so that's really 10 over y equals y over 4, like a geometric mean. All right, the next one is the mustache. There's a left mustache and a right mustache. So starting at one of the big numbers, one of the small numbers of the large hypotenuse, say I start at 10 again, there's a left mustache. I'm going to go left around the corner, around the side to x. Then I'm going to go from x back to the entire whole thing. So there's the left side of the mustache. So that is 10 goes to x, x goes to 14. And then there's the right mustache. So I'm going to start at 4 this time. Go around the corner to z, then back to the whole thing. So 4 to z, z to 14. All Alright, and I saw those three fractions. I get x, y, and z. No need to separate into small triangles. Or simple triangles to do proportions. Alright, so here we are. We're going to try the problem. By the way, if you know two known sides for a right triangle, you can always do Pythagorean theorem, and you should. Sometimes you're stuck and you have to do that. So it says find each variable. So first, let's do this. I know this is 6, this is 8 for right triangle. That means this has to be 10. That is a triple, 3, 4, 5 times 2. So we found x equals 10. Knowing that, I can then do left mustache. So 6 to 10, 10 to w. 6 over 10 equals 10 over w. Remember, you're supposed to reduce if you can. Make sure problem life easier. This is going to be 3 or 5. Equals 10 over w. Get rid of the fractions. Multiply both sides by 5. You get 3 equals 50 over w. Times both sides by w. 3w equals 50. Divide by 3. You get w equals 50 over 3. So this is 50 over 3. Alright, to find y, I could actually do 50 over 3 minus 6 to get the remaining piece. But I'm going to do y a different way. There's lots of ways to do this. Let's do around the world. So 6 goes to 8, 8 goes to y. So 6 goes to 8, 8 goes to y. Get rid of fraction, actually reduce, make life easier. So that is a 3/4, goes 8 over y. Get rid of fractions, let's multiply by, I guess, 4 first. So that's 3 equals 32 over y. Get rid of the next fraction, multiply by y. 3y equals 32, divide by 3. Y equals 32 over 3, and that does not reduce. Alright, so we found x, we found y, we found w, we need z. Now again, once you know any of the variables, you can plug it in and just use those numbers. So this is 32 over 3. Alright, notice I have the choice of doing Pythagorean theorem right here if I want. I don't have to. Or I could just do the right mustache, your choice. I'll do the right mustache. Or actually, you can do Pythagorean theorem for the entire giant thing. But I'll do 32 over 3 to z, z to 50 over 3. 32 over 3 over z equals z over 50 over 3. When you divide by fractions, you actually multiply by the reciprocals. This is z over 1, and this is z over 1. So if I do multiply by the reciprocal, I actually get 32 over 3z equals 3z over 50. I'm going to get rid of fractions. So I multiply both sides by 50, get rid of the first fraction, then multiply both sides by 3z, get rid of the second fraction. So I get 160 equals 9z squared. Divide both sides by 9, and then square both sides. Do the math, you get 4 root 10 equals z. So we found the last one. Now the numbers might be messy with radicals like this, but not always. On Gary Math, there are big numbers. You can use calculator, but they should be all whole number answers. Alright, in the last slide, sometimes they only make you find one thing instead of everything. So here, you have to figure out which pattern we're going to use. This one, we have to use around the world. So I'll start at 6, because one of the two small pieces of the large hypotenuse goes to x, x goes to 25. If you want to circle them, your choice. Alright, so 6 over x goes to x over 25. Get rid of the first fraction, multiplying by both sides by x. I do like this. So that is 6 equals x squared over 25. Get rid of the second fraction by multiplying both sides by 25. You get 150 equals x squared. Next, square root both sides. We square 150. That is 15 times 10. That is 3 times 5. That is 2 times 5. There are a pair of 5s. So 5 goes out, 3 and 2 stay in, which multiplied to 6. So we got x. Alright, that's it for the video. Make sure you ask questions, class. Thanks for watching. See you soon. Bye.